So can get it. So what will happen if the temperature of the glass cell is increased? Phyllis has told us that the smoke particles, their collision will be faster, isn't it?
Yes.
That is true.
Yes.
That is true. What makes them to be faster? Who can give us? Let me see if there anyone who knows what makes them to be faster. Let me first write that. The collisions between the smoke particles and air molecules will be faster. Because who can give us? Because now there is what we call, do you know energy? Do you know the energy of a body which is moving? Which energy is possessed by a body which is in motion? If you know. Is there anyone who knows the energy possessed by a body in motion? Yes, Phyllis. Wow, kinetic energy. Phyllis, you are the best. Kinetic energy. So, because now once the temperature increases, also the kinetic energy increases. Tracy, are we together?
Yes.
Even Faith, are you there with me?
Yes.
Yeah, so when the temperature is increased, when this temperature is increased, the collision between the smoke particles and the air particles will be fast because the kinetic, because the temperature, the increase, let me say the increase in temperature increases the kinetic energy of the smoke particles. So that's the reason the smoke particles will start colliding with the air particles because their kinetic energy has been increased. So this is what they are saying here. They are saying that rising the temperature of the cell increases the speed of random motion of the smoke particles. So that's what happens. That now the collisions between the smoke particles and the air particles will be fast because the increase in temperature increases the kinetic energy of the smoke particles. Good. And what if you decrease on the temperature? If you decrease the temperature, what will happen? Members, hurry up, we go to diffusion.
Yeah. To be the opposite of fast.
Are you sure it will be the opposite of fast? Can give us the answer. Can give us the answer.
Teacher, I'm trying.
Yes, Tracy, try.
The collisions between the smoke particles and molecules will be slow.
Will be slow, correct? Because
the decrease in temperature decreases.
Tracy, that is right. In fact, as someone said, the opposite of this is the answer. So Tracy, thank you very much. Today, I wish I had gifts, but I would just send you gifts, you people. I don't know. I just fail to get gifts here. Only gifts which are there. Let me just give you that, Tracy. Thank you very much. So that is correct. So the collision between the smoke particles and air molecules will be slow. You can say since a decrease in temperature leads to a decrease in kinetic energy. The smoke particles. All right, that is it, members. That is that is Brownian motion. Now we have seen that Brownian motion depends also on the temperature. Sorry, the temperature affects the Brownian motion, that the collisions will increase if the temperature is increased. So you should remember where we started from. We started from the definition of Brownian motion, describe the motion of the dust particles, describe the motion of pollen grains, demonstration of Brownian motion in a smoke cell, and we have now looked at all these members. That is good? That is good. Are you finished copying?
No.
No.
Okay.
Yes.
Okay, now as you copy and prepare yourself, I don't know where Otima has gone, but should come back. I don't know where he has gone. So let us look at diffusion in gases. Diffusion in gases. So you're going to look at diffusion in gases. Who can tell us? I'm going to start by asking you questions. First of all, we are going to first read here, and then we are going to ask ourselves questions. Then afterwards, I'm going to show you a video about diffusion in gases. Now let us see. Have you finished copying?
Yes.
Very good. So I can put this one aside so that we are not distracted. So they are saying that if someone is cooking in a kitchen and this person is cooking chicken and rice, are we together? It doesn't take long for the smell to travel around the house to other rooms. Members, is that true?
Yes.
Have you learned how to cook in this kind of recess?
Yes.
Okay. Do you know how to cook chicken?
Yes.
Okay, it is true. Now, when mommy or when you are cooking or when mommy is cooking somewhere in the kitchen and you are somewhere seated and then it is towards lunchtime, you feel that kind of smell coming towards you. For me, I call it the aroma coming towards you, and then you say, wow. Even sometimes when you bypass some places, let's say hotels, those places that prepare nice food, sometimes you feel that kind of aroma coming towards to you and filling up the whole place where you are. Now, what is the reason for that? They are saying that this is because of diffusion. It's because of what? Diffusion. You at home, you are seated in your bedroom or you are seated in a sitting room and the kitchen is somewhere far away.
Diffusion.
Diffusion. And even it may be outside the house and someone is cooking, but you feel that kind of smell coming towards you. You are not in the kitchen, but the smell is coming, and you feel really your the salivary amylase is trying to produce saliva because you're getting ready to eat. So it is because of diffusion is done which is bringing that smell. Now they are also saying that gas particles from a car exhaust fume. Do you know the car exhaust? That behind the part of a car where smoke comes from, it is called the exhaust. That behind the part. So the gas particles from the car exhaust fumes and perfumes or flowers diffuse through the atmosphere. They can diffuse through the atmosphere. So you can see the smoke that is released from the exhaust of the car, the perfumes from the flowers, the perfumes that we use on our bodies, the perfumes they use when in the house. All those things diffuse in the atmosphere. When you just press a perfume in one corner, in the other corner, you smell that perfume because that perfume has diffused throughout the atmosphere, throughout the atmosphere. So why? And they're also saying that our nose detects small particles. This is how we smell things around us. So there is a flower, you pass by a certain tree and it has good flowers, and the flowers are smelling nicely. So the reason is because of diffusion. Members, do you have any kind of example you give me where you have ever experienced diffusion? Apart from these ones which I mentioned? Yes, can you share with us? Who knows? You share with us any kind of example where you have ever experienced this kind of diffusion, where where something and you tell us.
In a supermarket.
In a supermarket. What happened there?
Like you smell because in some supermarkets they're selling food, like sausage, other things.
So you
can smell the
aroma, isn't it?
Yeah.
You can smell that aroma of food coming towards you. Thank you very much. That's good. Who else? Who has ever experienced this kind of diffusion? Noticed diffusion taking place somewhere.
Teacher, me again.
Yes, Trace again.
Also in a rubbish pit. Like if the rubbish is smelling badly, you can smell it.
Very good, very good. In a rubbish pit. Now, that one is going to take us to a video that we are going to watch about diffusion. And this video is, let us talk about the one where there is a rubbish pit. So let me look for that video and put here diffusion. Where is it? Where is it? Where is it? This one here. This is of chemistry. Okay, so let me show you this one. So let me show you this. 1, 2, 3, start. So we are going to learn about diffusion of gases, and you understand the behavior of diffusion in gases. So you need to ask yourself, why do things smell? And you need to understand the behavior of molecules in solids, liquids, and gases. How are these particles arranged? In solids, how the particles are arranged. In liquids, how particles are arranged. So you ask yourself, first of all. Let me ask one by one to give me. Let me start with, as we are watching the video, we are interacting. So let me ask one. Phyllis, how are molecules in solids arranged? Remember this, we studied this in chemistry, isn't it? We say that particles in solids, the molecules in solids are they packed? Are they so far apart? Are they close to one another?
They are close to one another.
They are close to one another. They are very packed. What about in liquids, Faith? Faith, in liquids?
They are fairly packed together.
They are fairly packed together. together. And then Tracy, how about in gases? How are they?
They are free.
They are free. They are far apart. They are free. So that's what this gentleman is asking. Pause the video and then ask students, how are those particles arranged? So you have answered correctly. In solids, they are packed. In liquids, they are fairly far apart. And in gases, they are far, far apart. So let us see. I think you have finished. So let us see. Particles in gases are spaced out. They are spaced. They are spaced. That's why you see them. They are spaced one another. This explains why diffusion is extreme in gases. Why we have diffusion in gases? Because the particles are far apart. Now, if you have rotten things like vegetables somewhere, there is smell. Suppose these vegetable things are packed in a container and then you leave them there and then you close that container. You close it and you leave them there for 1 week. These were vegetables, cabbage, what, and they are now getting rotten inside that kind of container, which is now closed. What will happen after some time when you come and open that container? They will be smelling. But now, before you open the container, there will be the smell of those rotten kind of garbage or what inside that container. The particles will be there. Those smelly air molecules coming out from this garbage will be packed within this container here. Now, once you remove the cover, now if you remove the cover, the particles move out and they spread in different directions. So now they are spread in different directions. And members, like how Tracy gave us the example, smelly garbage, that's how you can smell the garbage, because the particles diffuse in all directions, diffuse from one point which is concentrated. So inside the box here, inside this box here, there will be those smelly particles of garbage, concentrated. So this will be a region of high concentration. Members, are we together?
Yes.
Yes, that inside the box here, it will be a region of high concentration. Now, outside the box will be a region of low concentration, a region of low concentration. Now, once you remove the cover, the particles move from this region of high concentration to the region of low concentration, and that's what we call diffusion. That's what we call diffusion. So that's what we call diffusion. I'll stop there because there they are showing things that we have we have never noticed in Uganda, some of them. But you should know that this is a good example for you to know how diffusion happens. So diffusion, now you are going to give us, you are going to give me the best definition of diffusion, the best definition of diffusion. So everyone, as you are there, think about what is diffusion. What do you understand by diffusion? After watching this video, we are going to stop here on this video. After watching this video, where we had molecules in a container, and these molecules are here, and they are where they are, it is a high concentration. Now, when they move out, they diffuse to another region of low concentration. And now I'm going to ask you, what do you understand by the term diffusion? So who can give us the answer? What do you understand by the term diffusion? Who knows the answer? You can discuss amongst each other if you know. That will be here in your discussion, but you can discuss. For me, I'll first keep quiet. You first discuss. You ask each other. You know the answers. Okay, let me start with Faith. Faith, what's the answer of diffusion?
Diffusion is the movement of molecules from a region of high concentration to a region of low concentration.
Diffusion. Diffusion is Faith, come again.
Diffusion is the movement of molecules from a region of high concentration to a region of low concentration.
That is correct. That was Faith, isn't it?
Yes.
Yes, Faith, thank you very much. That is a brilliant answer. That is the most correct answer. So everyone, can we write the definition of diffusion? Including me, I'm going to write what we understand by diffusion. Okay? So everyone write. This man has given us the answer. So can we go back and you see diffusion? So have you written the answer?
Yes.
Yeah, everyone has written. Huh? I'm trying to connect my camera here. Very fast. Come on, very fast. So diffusion is the movement. We can say is the movement of molecules from the region of high concentration, to the region of low concentration. Okay, no concentration. Okay, now here they are telling you that if you don't have to mix the gases by waving your arms around, they mix on their own because they can move and they can mix on their own. We have seen Brownian motion that they also move randomly. So it's also saying that you can easily show this with a gas that has a smell such as butane in a burner. One person should turn on the burner and then a few seconds and see what is in front of this person. So members, are we together? Members, are we together? Yes. So we are going to demonstrate a demonstration of diffusion in gases. That's our heading, demonstration of diffusion in gases. How demonstrate diffusion in gases? How do you demonstrate diffusion in gases? So members, the steps are here. That what do you need? You need gas of bromine vapor. And what's the color of bromine? It is what? What's the color of bromine?
Reddish brown.
Reddish brown. It is reddish brown. So the color of bromine is reddish brown. Thank you very much. So we need gas of bromine vapor. We need 2 empty jars and a cover plate. Now, members, I'm going to show you this experiment. But before I show you this experiment, let us first read through and see. Now, saying that bromine vapor is a poisonous and should not be inhaled. So in our lab, I think we don't have bromine vapor, but it's there, though it is made in a careful way so that we don't inhale bromine vapor because it is very poisonous. Now, what they are saying is that the first thing that you have to do for you to demonstrate this is that fill one of the glass jars with bromine gas and carefully cover it with the open plate. They're saying that fill one of the gas jars with bromine gas and carefully cover it with a plate. Then insert the second gas jar and place it on top of the jar full of bromine with its cover. So let me first write the first one. So the first one, they are saying that. So how do we summarize that? If you're writing your notes very well, so you write that one gas jar is filled with bromine gas and carefully covered with a plate. Are we together? With a what? With a plate. Members, are you following?
Yes.
Now the
Yes.
second thing they are telling you that insert the second gas jar and place it on top of the jar full of bromine with its cover. So what are we going to write there? So we can say the second, the second empty gas jar is placed on top of the jar containing bromine gas. Now the next step is you're saying carefully remove the cover plate and let the two open ends of the jar connect. So I'm going to show you this video in the next 5 minutes. So they're saying that carefully remove the cover plate and let the two open ends of the jar be in contact. So they are saying that now the cover plate is removed. Full stop. And lastly, they are saying that do not move the jars. Look at what happens to the bromine gas. So we can say the cover plate is removed and the gas jars are observed. So members, in case this lesson ends, we shall start from here, but let us first look at our video of this experiment and then you get to know what is taking place with this experiment, because I cannot prepare that bromine gas. It's very poisonous. So what we have to do, let us use YouTube. That's why Zoom is very good now. We can just connect to YouTube very fast and then we can watch these things. Okay. Somewhere here, Diffusion. So this one here. Okay. That's an advert. We're waiting for this advert to end, wasting our time. Okay. Internet problem? Not internet problem. There's a problem here. Okay, let us watch our video. So they are saying that water vapor spreads out in the atmosphere Why? Because it is, I mean, smoke is spreads in the atmosphere because it's carried by the air. So gas particles just move randomly. That's how gas particles move. So now, this is the first jar containing bromine gas. Let me first take it back there. That is the jar containing bromine gas, and it is reddish brown. The gas is reddish brown. So one glass is there containing, remember our first, if you have been writing, we said one gas jar is filled with bromine gas and carefully covered. So this is the glass jar. This is the jar that is containing bromine gas, and it is now carefully covered. So what will happen next? So our next step, they are saying that the second jar is placed on top of the jar containing bromine gas. So the second jar, that is the second jar which is empty, it is placed on top of the first one which is containing bromine gas, and the cover is removed. You are seeing is removing this cover. Let me show there very well. The cover was removed. Is removing it. Now we take, let us observe what happens. Now you see how bromine is spreading. It is spreading from this jar that is containing, from the first jar to the second jar that was empty. So after half 1 hour, this is what will happen. That now the two jars will, let me take you back. After half an hour, this is what will happen, that now the two jars will have a uniform distribution of the bromine gas, So in the first jar and also in the second jar, we will have bromine gas. But initially, what was there? Initially, it was the first jar. The first jar was there and it was having bromine gas, and the second did not have bromine gas. Now, once we connect, and then we remove the cover, bromine gas starts to spreading from the first jar to the second jar. So it is spreading from the region of high concentration to the region of low concentration. So after half 1 hour, this is what will happen. So they are telling you that now the bromine gas, that's how it keeps on spreading. The white ones are air particles and the reddish ones are the bromine particles. So they spread out and now they are filled to one another. So let me pause. Let me pause there. Come on. Okay. So members, you have seen that experiment, isn't it?
Yes.
You have seen that experiment. So can we now explain our observation? First of all, what is observed? What is our observation? Can you tell me what do you observe after? So let me write after some time, comma.
Observation.
After some time, you can give us the observation. We have 3 minutes, members. After some time.
The teacher me.
Yes, Tracy.
The air molecules will move freely.
Air molecules or bromine gas?
The bromine gas will move freely into the other jug on top.
Okay, so we move freely. Thank you very much. So the correct word which we can say there, we say that bromine gas, the molecules of bromine gas, the molecules of bromine gas diffuse. Do what?
Diffuse.
Diffuse from one jar of high concentrate. Diffuse from one jar of high what? concentration. Are we together? Diffuse from one jar of high concentration to another jar of what? Of low what? Members, are we together? Of low concentration?
Concentration.
Of low concentration. So that's what we shall observe. The molecules of bromine gas diffuse from one jar of high concentration to another jar of low concentration. Are we together? So that is the observation that we shall observe. And another thing that we shall observe, we shall also observe a uniform what? We shall have a uniform distribution, isn't it? A uniform distribution of bromine gas in both of the gassy jars. So there will be a uniform distribution of the bromine gas in both of the glass jars. Reason is that the molecules of bromine gas diffuse from one jar of high concentration to another jar of low concentration. Remember, this observation also can be the explanation. Are we together?
Yes.
Yes, can be explanation. Now, members, I would like to end here our lesson. Next time we meet, we shall look at the factors that affect the rate of diffusion. So when you look in your book, that's what we have looked at. I thank you very much for being a good class. And if you have questions, you can text me on WhatsApp and I can give you the answers from there. Is it okay? Phyllis.